Alright guys, so now we are going to talk about the section 2.3, stretching, shrinking, and reflecting graph. So, first of all, vertical stretch. You will have a vertical stretch every time you are going to have y equal a times f of x, with a number greater than 1. Okay? When you look at the example number 1 right here, as you can see, the value of y, what was 1 when you have for square root of x. Now you have 3 times the square root of x, so the value of y is going to be 3 times 1, which is going to be 3. The value of 2 is going to, obviously, 3 times 2 is going to be 6, okay? That is what we call a vertical stretch, okay? Because we stretch the function, vertical stretch. Now, you could have exactly the same thing with a vertical shrink, and I'll let you write what is a vertical shrink. Please take a look at your book to see what is missing the definition of vertical shrink. If in case I forgot to put a red dot, read thoroughly your note, and you will see where it's missing something, okay? Let's take a look at the example number 2 about the y-axis reflection. And when you look at the example number 2, and as you know, you can read the definition of the y-axis reflection. When you look at the example number 2, if I decide to have on the same graph the function f of x equal square root of minus x, and the function f of x equal square root of x, well, I can see that basically I'm going to have, oops, not like that, so let me try to do something better than this. I'm going to have something looking like this. And I can clearly see that the y-axis is playing the same role than a mirror, and that's what we call the y-axis reflection. Okay, so when you have a y-axis reflection is when you have the y-axis playing the same role than a mirror. Now, if I do the x-axis reflection, the definition is more when y equal minus the function of x. And this time, instead to have the y-axis playing the role of a mirror, you will have the x-axis playing the role of a mirror. Let's try to look over the example number 3, and let's try to graph the function f of x equal minus square root of x. If I take a look at the graph, what do I see? I see clearly that I have the x-axis playing the role of a mirror, and if I graph on the same graph the function square root of x and minus square root of x, I'm having the mirror effect, and this is f of x equal, oops, let me use another one. If that is f of x equal square root of x, this one is going to be, this one is g of x is going to be minus f of x. Okay? Alright guys, so now let's take a look at this example number 1 and 2 for the vertical stretch and vertical shrink. I will let you do the example number 2 on your own, and I'm going to try to do the example number 1 with you. Don't forget to add right here the definition of vertical stretch and vertical shrink, as well as right there the definition of x-axis reflection and y-axis reflection. So now, example number 1, I'm looking at basically a function f of x equal a function 2 times the function g of x, knowing that the function g of x is absolute value of x. So if I sketch roughly the function g of x. All right. Now, if I want to represent the stretch, the vertical stretch, well, every single point, and actually, what I'm going to do is I'm going to raise up to here. I'm going to represent my function tiny bit shorter than it could be, because the point who was here, this point right there, is going to be, which is a 1, 2, 3, 4, now is going to be a 8. So I'm at 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. So now my point is right there. The point who has, on the other hand, 1, 2, 3, 4, 1, 2, 3, 4, 8, same thing. This point right here is going to be a 8, okay? And the point who has a 0 is at 0. So obviously I stretch, and I had a vertical stretch. I will let you do the example number 2 on your own, as well as the example number 3 regarding the y-axis reflection and x-axis reflection. But right away you should see that what do you have right there is a function f of x equal minus another function g of x. And that should help you to define, based on the definition of y-axis and x-axis reflection, which reflection I'm talking about. So, let's jump on the example number 4. And let's try to do the example number 4 together. If I want to do the example number 4, what do I see? Well, what do I see? It's pretty simple. First of all, I see that my function f of x is equal to a function g of minus x, knowing that g of x is x squared. So g of minus x is supposed to be minus x squared. And when I have that, I'm supposed to have a y-axis reflection. So what I'm going to do is pretty simple. I'm going to have to graph f of x equal, give me a second. All right, so I'm going to have a x-axis reflection and not a y-axis reflection based on the definition. And so if I'm going to have a x-axis reflection, first of all, I'm going to graph, this is f of x equal x squared. And if I'm looking at a x-axis reflection, that means my new function is going to be like this, and this is f of x equal minus x squared. Okay? So let's try to do the example number 5 together, and I will let you do the example number 6 by yourself. So first of all, what I want to do is represent x cubed. So if I want to represent x cubed, what I'm going to do is what? I want to do x cubed first. So first of all, I'm going to represent in red f of x equal x cubed. Then I want to represent f of x equal x minus 4 cubed. Because of the minus 4 right here, okay, I'm going to have a shift, and it's going to be an horizontal shift, and it's going to be to the right of 4 units. So I'm going to have 1, 2, 3, 4, and basically I'm going to have is something looking like this right there. Now I'm at f of x equal x minus 4 cubed. Now what I want to do is what I want to do now is taking care of the negative 3. Okay, so I'm going to try to represent on this second graph f of x equal negative 3 times x minus 4 cubed. Obviously, what I want to do is I want to have a, so let me change the color. I'm going to take a good green. And I want to do is try to understand that what I'm going to have is a y, kind of a y reflection. And so at x equal minus 4, 1, 2, 3, 4, okay, if before I was dealing with this function f of x equal x minus 4 cube, now what I'm going to do, what I'm going to have is going to be, what I'm going to have is going to be the opposite, which is this. And actually I should have used the blue, so let me do that in blue. There we go. This is minus 3x minus 4. With the minus right here, we're having a reflection with the y-axis, this y-axis reflection. And now I have plus 5. That means I'm having a vertical shift, and this vertical shift is going to be up 5. So everything is going to move to the top. And let me use another color. All right. And what I'm going to have now is I'm going to have 1, 2, 3, 4, and I'm going to have is something looking like this. All right. And this is f g of x. This is your g of x. And this is your g of x equal negative 3 times x minus 4 cubed plus 5. I will let you do the example number 6 by yourself. And if you have any question, we'll talk about that in class when we will solve the different problem coming from your book. Thank you.